Hey guys, welcome back. This should be, I think, the third video in the series. And today we're going to talk about LEDs and timers and yeah, essentially how do you combine both and how to set it up so that you can have timers that run sort of in parallel with your code and that they don't interrupt anything. Yeah, let's get started right away. So the first thing you're going to need is you're going to need two LEDs. Now, I invite you to actually try using 3 LEDs at home and 4 LEDs with different timers once you've watched this video so that you're actually familiar with everything. So let's go ahead and pick 2 LEDs. I am going to use personally a red LED, and I am going to also use a, why not? Let's use a blue LED. Okay. The next thing you're gonna need is 220 ohm resistors. So for this, I just need to find them. They're somewhere in my hand. You're gonna need 220 ohm resistors right here. Cool. Now, I'm not going to go too in depth with the actual wiring. I will show you guys the diagram that I'm following, and I'm gonna somewhat explain as I go. But the idea of these videos is to focus more on the software side. In terms of cabling and stuff like that, I'd rather do it in lab because it's easier to answer questions essentially than in a video. But I'll still try to kind of cover it. I'll just sort of show you guys what I'm using as a reference. I'm using this right here. So they tell you, by the way, what to use. So 220 ohm resistors, the LED, and then jumper wire cables. And then they show you how to wire it, right? So I'm going to get rid of this middle cable here, and I'm just gonna connect. So if I just take this and show you guys what I want to do exactly. I want to connect this here. Oh, sorry. This here to this, and I want to connect it directly. So it's gonna look something like. Okay, it's a little hard actually to move it, but essentially something like this. Right, and then I'm gonna have a because this one's the data pin, so I'm gonna use an actual yellow cable, and I'm gonna go damn it, straight to my 13, and I'm going to do this 2 times. Essentially, I'm gonna copy the same exact thing 2 times. Now, something you'll notice is that it needs to be grounded like everything else. So this here, you can see it right here, it's grounded, and instead of grounding it separately, because I only have 2 ground pins, I don't want to use them all. What I'm going to do is I'm going to connect this to my ground rail at the other LED here, let's say, and connect this to the ground rail as well, and then later on I'm going to connect the ground rail to my GND, to my ground pin, and that's gonna ground everything. I don't need to actually do it separately. So the other thing to notice is that one side of the LED is longer than the other. The longer side is going to our data pin, so it's going to power. The shorter side is the one that is going to ground. Okay, so let's go ahead and just start by putting the LEDs. So I am going to go right here, put them nice over there. I'm gonna open some space for this one and do it over here, just because I want to ensure that I have enough space, because the resistors are kind of hard to put in actually. So these again are 220 ohm resistors. So this one's gonna go here, this one's gonna go here. Make sure they're actually connected to the board, to the breadboard, because otherwise you're gonna have trouble turning them on. Same thing for this one. Make sure you have them in there. They're actually kind of annoying to put in sometimes because well, they're just kind of finicky. but that should be fine, I think. Let me just make sure. Okay, I think it's good. Worst case, we'll see it. And then we're going to, let's first ground it. So remember from last video that in the middle, the breadboard is connected by the column, and the power rail and the ground rail are connected horizontally. So let me make sure that I'm actually showing. Yeah, okay. So horizontally at the top. Sorry. Horizontally at the top, and in the middle it's kind of vertically. Cool. So now we're going to ground it. So I'm gonna use 2 brown cables to ground them. I'm just gonna do what we just talked about, connecting in that same, that short side of the pin to the ground rail. So short side of the pin. Let's use the other side to the ground rail. Short side of the pin to the ground rail. So it looks something like this right now. If you want to pause it. It's a little hard to show it, but essentially short side is connected to the ground rail now, which is the blue side here, and you have your resistor that is going to be used for your data pins. So the last thing is obviously grounding. Oh yeah, make sure you disconnect your board. But the other next thing is using another brown cable or black cable, whatever you have at your disposal. I have a blue cable apparently. I'm comfortable doing this because I've done this many times, but it's easier if you do the proper way, so using the proper color. So now I have everything grounded, and the last thing I need is to connect my cables, so my LEDs, to my data pins. In this case, I am going to connect my LEDs to pins 10 and 11 on my board by using 2 yellow cables. If I can find the other yellow cable I had, I guess I might as well just open a new one right here. So I have now 2 yellow cables. I'm going to connect them from the resistor as instructed in the diagram that they gave us, from the resistor to the data pin. So I'm going to use 10 for blue and 11 for the red. Okay, once I have my wiring done, before we go like super in depth on how to code it properly, I'm just gonna set up a quick test. So the first thing we need to do is set the pin mode. I'm gonna put my camera back up. Actually, it's gonna be easier if I do this so I can show you guys the colors. So pin mode of pin 10 to output. So all I'm telling the board is, hey, I'm gonna be powering something through pin 10, and I'm gonna do the same thing for pin 11. So through pin 11, I'm gonna output some voltage. And then here I'm gonna turn them on. So for that, we can use digital write. We can set the pin to high, and same thing for the other one, 11, high. And this should turn on both of my LEDs. Let's just give it a shot and see what happens. I am currently not connected to my USB, of course. So let me connect my board first. I'm going to try again and upload it. Cool. And there you go. Both LED lights are on, so I know that my circuit works perfectly well. If you don't have both of your LEDs lighting up, you're most likely doing something wrong with your resistor. Make sure that your connections work properly, and that your resistors are actually pretty well connected to the metal part behind the breadboard. So today we're going to talk about timers and making the red LED blink every 2 seconds and the blue LED blink every 3 seconds. Okay. So how do we do that? Well, when you connect your board to your computer, the board doesn't actually know what time it is. It doesn't know that it's 8:13 p.m. for example right now, or that it's gonna be 3 p.m. tomorrow. It doesn't matter. It doesn't know what time it is currently. All it knows is that X amount has passed since it turned on. So the moment you turn it on, it starts some sort of master timer, if you will. So it kind of keeps incrementing until you turn it off. Okay, it's until you turn it off, or until, well, actually, yeah, until you reset, until you turn it off, it will keep going. So it looks something like, give me a second. I just recorded the other video, so I'm just gonna move this. So it starts at 0, and then it keeps incrementing 1, 2, 3, 4, and so on, right? And this would be in ticks. It's not even in milliseconds. It's very, very fast. So what you need to do to, let's say, have a timer is you need to essentially first store the beginning of your timer. So let's say this is the start time, and then calculate the delta. So how much time has passed since you started the timer and the current time. So let's say this is current. It's been, let's say seconds in this case. It's been, or milliseconds. You know what? It's going to be easier. If we go from start time to 4, this delta is 2 milliseconds, right? And if I wanted to do something every 2 milliseconds, all I have to do is check whether my start time or my current time minus my start time is 2. Okay, so let's say instead I'm going to, if we're talking in milliseconds, I'm going to use hundreds. So let's say it's 100, 201, 302, and so on. I'm going to show you guys what it actually looks like, but just bear with me for a second. It's going to keep increasing, right? Boom, boom, boom. Done. And then it's going to say, like, I don't know, 1,600. Oops. And then it's going to keep going. And then it's going to go to 2,204, let's say. So this, let's say, is my start timer. And I want the timer every 2 seconds. Basically, I check for the delta. So this is what, 100 millis. That's not 2 seconds. So we keep going. Then it calculates the next one, next delta. It's not 2 seconds, keep going. And eventually we're going to get to 2,204. And I'm going to realize that this is approximately 2,000 millis, which is 2 seconds. And now that I know that 2 seconds have passed, I can do whatever I wanted to do. And then I restart the timer, and then we go again. So just to visualize this a little bit better, what I'm going to do is I'm actually going to print out serial.println millis, which returns to me the amount of time that has passed in milliseconds since I turned on the board. So let's go to serial monitor, minimize this a little bit, and you can see right here that it keeps increasing in milliseconds. And what I was telling you earlier, let's say I start my timer at 133. Well, if I keep doing the delta until I make it to 2,137, I won't know that 2 seconds have passed. That's the basic idea. Once I do this, once I checked if 2 seconds have passed and it's true, I do whatever I want, and then my new start time becomes this, and then I keep going. So I go to, what is it, 4,130 something. There we go. Right, and now we know 2 seconds have passed, and then we restart the timer, and then we go again. And that's the basic idea of timers. So let's just write down sort of in terms of English, what do I need? Well, I need some way of storing the start time, right? I need to basically calculate the delta time. So current time minus start time. And then if it's bigger than or equal to, right? Because it's never precisely 2 seconds, especially in milliseconds. It's like close to 2 seconds. If it's bigger than or equal to, like, let's say 2,000 for 2 seconds, then we do whatever task we had in mind, and then restart the timer. Because we want to do this every 2 seconds, correct? Okay, so now we have an idea of what it is that we want. So let's take a look. So let's first start with the start time. So start time, right? And the reason why we need a long, and we actually might need an unsigned long, is just because if you use an int, it's actually too small. It overflows the buffer right away, especially in milliseconds. So we're gonna have start time. Okay. What else we need? And then we need to basically just get the delta time and then an if statement. So let's go to our loop. Actually, first let's start our timer, right? So at the very end of our function, we're gonna call millis, and this just basically I'm storing the beginning of my timer. At this time, I started calculating or trying to find the delta. Cool. Now I have this. Now when I go to loop, right? Now here, what I can do is I can check if the current time. So if millis, which returns to me the current milliseconds, minus start time is bigger than or equal to 2000, then we know 2 seconds have passed, right? I mean, I can actually print this first. 2 seconds have passed. We can actually print this first and just see what it yields. Let's go to serial monitor. Actually, you forgot one thing. I forgot to restart my timer. So 2 seconds have passed. It's just gonna keep saying 2 seconds have passed. Let's fix that. So all I have to do is say start time is now equals to millis. So I restart my timer, and now I'm gonna have something that runs every 2 seconds. So let's take a look. Let's upload it. Go to tools, go to serial monitor. Both my LEDs are on, so it's going. There you go, 2 seconds have passed. Again, look at that, 09, 11, 13. We can tell that 2 seconds have passed. Now, notice that the milliseconds are actually not at all the exact. This is why we have bigger than or equal to, because otherwise it's not gonna work. It's not gonna work. You want something that is kind of like accurate. Sorry, I got a little distracted. But you want something that's like decently accurate, and so you always want to use bigger than or equal to 2000. It's never gonna be exactly 2000, right? Okay, so now we have 2 seconds have passed, but we said that we're going to be toggling the red LED every 2 seconds. That means I'm gonna be turning it on and off. So let's take a look here for a second. How will I be able to do this? Basically, I can't just digital write pin 10 and then high. I can't do that because I need to be able to turn it off as well, right? So what I want to do is I also want to store the state of my hardware. This is something that is very useful. Usually you want to store how, like in terms of software, you want to know what the hardware is doing. So a new variable I'm going to introduce here is a boolean that can tell me whether the red LED is on or not, and it's gonna start as false because it always starts at false. And actually, let's go ahead and fix the pins, because last video we talked about how all your pin numbers should be a constant. So let's say red LED pin, this one's gonna be 11, and blue LED pin is gonna be 10. And let's change it. Let's think of that right away. Let's take care of that. I'm gonna remove this. Cool. Okay, so I have my red LED pin, my blue LED pin, and I have a way of storing whether or not the light is on. And now I can actually just say, well, if is red LED on, if this is true, then we have to turn it off, right? So if in real life the LED is on, then oops, we're gonna set it to we're gonna turn it off. Else we're gonna turn the LED on. And by the way, high and low basically means on and off. Low means it's low voltage, high means high voltage, and for the LEDs to work, basically to turn on, you need high voltage. So once we have this, make sure that you also store the state of your hardware. You update the state of your hardware. So if it's low, then this is false, right? If it's off, it has to be false. And if it's on, then this has to be true. And there you have it. I'm gonna upload my thing. I'm gonna go over the software once again after I show you guys how it works. And there you go. Every 2 seconds, it's gonna turn on and off. You can see it right here, on and off. So let's go over it one more time. We have my pins here. We have a way to store whether my LED is on or off. A start timer. I start my timer, and then I check how much time has passed since the beginning of the timer. If it's more than 2 seconds or equal to 2 seconds, I'm going to toggle the LED, and then I restart my timer. And I can do this for my blue LED as well. And the nice thing is that I don't have to change much. Here I'm gonna do start time red, and I'm gonna make another variable, start time blue. And we're gonna do the exact same thing here. So start time blue equals millis, start time red equals millis, and I'm basically, it's the same exact thing. So this one's gonna be start time red, start time red, and we're gonna do the same thing. If millis minus start blue, start time blue is bigger than or equal to 3 seconds, let's say, we're gonna have to, oh yeah, we also need a variable to store whether the blue light is on or not. So it's always set to false. Now we just basically copy paste. So if the blue light is on, then we want to turn it off, right? So blue LED pin low. We update our hardware, or our variable that stores the state of the hardware, and then we do it again. So digital right red, blue LED pin high, so turning it on, and then we update the state of our hardware, and then we just restart our timer. So start time blue becomes millis. And just like that, I'm gonna upload it, and let's take a look. So there you go, every 2 seconds and every 3 seconds for the blue LED. So if you count it, let's just wait a second. 1, 2, 3, 1, 2, 3, 1, 2, 3, and so on, right? This one's every 2 seconds. So if we let it 1, 2, 1, 2, and so on. Cool. That's basically that's basically it for today. So we learned how to do timers. The reason why timers are important is because I can actually keep coding. I can actually do other stuff here, and the timers will not disrupt my flow. So I can keep doing other things in parallel with my timer. I don't need to stop everything while the timer is running, which is an extremely useful concept to have. But yeah, that's basically it. Next video, we're going to be talking about analog inputs and averaging inputs, and yeah, basically being able to use the light sensor. All right, see you guys next time. Bye.